We now move into the SPI core driver. So in here, I'm showing you a couple of columns or a couple of files. The first one is actually the SPI core header file, and this one here is actually the implementation. So again, taking a look at the header file tells me how to use that particular driver. And the first thing we have is we have some sort of an enumeration here that tells me the first one is the read data register, which is offset 0. The second one is actually slave select or offset 1, and offset 2 is whatever data you want to send. And the last one is a control register. And the control register is actually decoded in here, or actually it's stored in here. So we in that, if you remember, we have the divisor and the C phase and the C polarity in here, so they're all stored in here, okay, in the private section, so we can actually keep using them over and over. So we store them in the driver. And we have another enumeration, and this enumeration is for the read data, because whenever we read that data in here, we have the whether it's ready or not, and the data that we care about, which is here is 8 bits. Okay, and the slave select as well is stored in here. I forgot to mention that. Okay, so the slave select the whole register, which in our case should be 1 because we're only using 1, but the driver is flexible enough so we can change it if we choose to. So taking a look at the member functions and the methods. So we have a constructor destructed, let's take a look at how it's implemented. And it's implemented in the following. It just basically stores the base address like any of the other cores, and then it sets the frequency. Basically, the SPI frequency is set to this 400,000, which is basically 4K or 400K hertz. And it sets the mode 00, basically sets it to mode 0. That's by default. And then it writes to SS, basically deasserts all of them. Basically, it makes sure that none of the slaves is selected. So this is what, whenever you create an instance of this particular driver, it's just basically setting some default values. So of course, where did these functions come from? Well, they're actually inside the driver. So we're just using functions from the driver. So the ready signal in here, it's not used in the constructor, but its purpose is just to read the status of the SPI, whether it's sending some data or whatnot. Setting the frequency, this is what we saw, and setting the frequency is as straightforward as just writing something to the divisor. So if you take a look at the setting the frequency in here, you'll see that all it's doing is actually taking whatever frequency we have. It computes some sort of a value. That value is a divisor, and we do the -1 because we want it to count from 0 to divisor -1, so that it's not divisor +1. It's like that. So what we're doing is we're doing the -1 in the processor as opposed to doing it down there in the hardware level. And then what we're doing is we're keeping the value of C phase, we're keeping the value of C phase. We're keeping the values for both the C phase and the C polarity. I think there's a typo in here. One of them should be C polarity, one of them should be C phase. So I'm just going to correct that. So we have the C polarity in here and the C phase. Okay. Okay, there's a type on the driver, so the C-pol and or the polarity, which is basically we're constructing that offset. I believe it was the last one, which is offset 3, and then we're just writing it, and that's the control register, which is offset 3. So you can see it. I think it's in here, control register 3. Okay, we go in here. The same goes with the set mode. Okay, so we have the polarity and the phase, and what we do is, again, what we have is we have this, I think this should be polarity as well. Okay, similar to that, there's actually a typo in it. So we have it so that we construct them. We get like new modes. This is basically the set mode. And the rest of them is actually for the slave select. There's a few of them. So there's one that you can tell it basically 32, all of them basically as a one word, or you can basically specify which one you want, whether you want basically to be asserted or deasserted. And then you can actually assert a single one. You can just, these are very similar. So in here, you can actually deassert or assert all the slaves together, basically all 32, all up to 32 of them. And in here, you can specify a single one of them and actually either deasserted or asserted, but you're going to have to provide the value and the number. And in here, you just basically, it's just a shortcut. It tells it to assert that particular slave and then deassert that particular slave. And if you take a look at how these assert and deassert are used, they're actually using the right SS. Basically, it's telling me assert is actually at 0, the number n, basically as if you're passing it to that number. Okay, and then the last one is actually, which is the most interesting, which is actually the transfer. Transfer is actually when whatever you want to send. So the transfer it's not send and it's not receive. It's actually transfer because it's doing two things. It's actually sending whatever you pass to its parameter, and it's actually returning whatever it read from this slave. So taking a look at the implementation itself, it's actually doing And it's waiting basically for the read to be, basically for this SPI core to be ready. It's just doing nothing in a while. Once it's ready, it's actually writing to that. And if you remember, once you write to that particular offset, it will actually send it, and it will wait till it actually is sent. And once it's sent, I know that not only did it send, but the current value is actually whatever the slave sent, and it's actually in the read register. We're just going to read it, and we're just going to basically return it. And now I have whatever I received and whatever I sent.